Good morning. We're going to see in detail about the friction. Friction is nothing but a force that acts in between the two contacting surfaces. Whenever an object is in contact with another object, the frictional force will occur over there. When a body tends to move over another body, a force opposing the motion of the particular object is known as the frictional force, or we can simply call it as friction. In this image, we are able to see that the pushing force is there on the block. The block is in contact with the floor. While we push the block on the left side, the block moves towards the direction of the pushing force, so that the frictional force will be opposite to the applied force at the point of contact. We'll able to see that the frictional force is here, the point of contact, that too in the opposite direction of the applied force. Friction is the force distribution at the surface of contact between the two bodies that prevents or impels sliding motion of one body which is relative to another. The force distribution is tangent to the contact surface and has for the body under consideration a direction at every point in the contact surface that is in the opposite to the possible or existing slipping motion of the body at the point of contact. The force, the frictional force, is always a tangential force that is on the surface of the object which is over there. The friction is of three types, that is static friction, kinetic friction, and rolling friction. Here is the examples of static friction and kinetic friction and rolling friction. The laws of dry friction, that is coefficient of friction. Here, the coefficient of friction is mu. Based on the value of mu, we are able to understand that whether the object is in rest or it is about to move, that is impending motion, or it is in motion. Here in this image, we are able to see that a block, there are two images over here. The block is rest on a flat surface, on a table. While we considering the free body diagram of this block, the weight of the block acts perpendicular to the ground plane and the normal reaction acts perpendicular to the lying plane. When a force P is applied in the block starts moving, or a force might cause the block to move. So that whether the force might cause the block to move or the force applied doesn't give any changes to that particular block, whatever might be the conditions, the frictional force is acting on that particular block. That is opposite to the applied force. We are able to see here. So this is the free body diagram of an applied force of a block. Now we'll see in detail. A block of weight W placed on a horizontal surface. Forces acting on the blocks are its weight and reaction on the surface. Yeah. The horizontal force P is applied to the block for the block to remain at stationary in equilibrium conditions. As P increases, the static force F increases until it reaches its maximum value of F1. When we keep on increasing the value of P, at one point of time, it will get started to move. That is mentioned over here. If P increases, the static friction force F increases as well as until it reaches the maximum value of F1. Further increase in P causes the blocks to move as F drops to a smaller kinetic friction. That is Fm is equal to mu into N, whereas the kinetic friction occur over there, Fk is equal to mu k into N. 4 situations that can occur when a rigid body is in contact with the horizontal surfaces. Case 1. When the applied force P is on a vertical direction. Therefore, here while we solving, the system is in equilibrium conditions. Here the frictional force is not there. Therefore, while we solving this by considering the system is in equilibrium, we'll get sigma Fv is equal to 0. The n is in the positive direction and the P and W are in the negative y direction, vertically downwards. Therefore, the n is equal to P plus W. N is nothing but the normal reactions for this block. Here the frictional force is no frictional force is there. Therefore, Px is equal to 0. The value of P will be equal to 0. When the P is inclined, we have to resolve into Px and Py. While getting the equation for a horizontal motion, we'll get the equation as Px in the positive direction and F in the negative direction. Therefore, Px minus F is equal to 0. Therefore, F is equal to Px. Here, the F value will be lesser than the system is in static condition, so the F value will be lesser than the coefficient of friction into normal reaction. The normal reaction N is equal to Py plus W, as we already seen that for the vertical reaction, sigma Fv is equal to N minus Py minus W. Here we'll get the N is equal to Py plus W. For the third conditions, motion in impending. Here for the horizontal component, we'll get the equation as Fm is equal to Px. Since the motion is in impending, that is about to move, the Fm is equal to Px. It relates with the Fm is equal to mu s into n. It is about to move, mu s. The value of mu s matters here. It is about to move, so that Fm is equal to mu s into n. Whereas in the previous case, when there is no motion, F is lesser than mu s into n. For the case over here, Fm is equal to mu s into n. The same equation, n is equal to Py by Py plus W for the vertical force. When the object is in motion, that is kinetic motion, the same equation will be rewritten as Fk is lesser than Px. The frictional force will be lesser than the applied force. In that case, the object will be in motion. So while considering these 4 different conditions, that is when there is no friction, when there is no applied load, applied force, there will be no friction. When the applied force is lesser than the frictional force, the object will be at rest. There are also no motion. About to move, that is impending motion, the condition Fm is equal to mu s into n. The applied force will be equal to the frictional force. Whereas for the last condition, when the object is in movement, the applied force will be greater than the frictional force. For the Fk is equal to mu k into n. Thank you.